Well, hello again everyone, and welcome again to this video where we are going to talk about how you go about doing a 4-point balance on the bell of a motor by using our propeller balancer software. So you can see here I have set up the screen, the program, and in this situation we really do not care about any sort of orientation with the propeller because there is actually no optical beam that's going to get involved. It's just basically working with the raw parameters of the accelerometer to give us values that we can then determine at which point our bell of our motor is unbalanced. The way we start here, as you can see, I have my rig already set up, and I will tell you a little bit how I proceed to give a test here as to how we're going to test the motor. And on our software here, we don't again worry about any of the invert X and Y's. Obviously we probably want to be at a 2G mode for the accelerometer. That will make the accelerometer the most sensitive. And as you can see here, we'll click on the 4-point balance and you'll see that the motor goes away, and we have a picture of our motor. You'll also notice that on our motor we have marked a 0, 120, and then a 2, another 120 degree apart mark. So the mark from here to here is 120 degrees, 120 degrees, 120 degrees. Times 3 will basically give us 360, because that's where we want to be placing the trial weights. And we have done, I don't know if you can see it here, have pretty much the same marks on our motor. Have a mark here at the 120, another 120 degree apart, and have a mark on the top here that's 0. And what I'm going to do here to actually show you how this thing is work, I'm going to purposely unbalance the bell of this motor. So I am again going to take a very high piece of tape here, a little piece of foam tape, and I'm going to arbitrarily basically place it, I don't know, let's place it somewhere here on the bell of the motor. And this will basically make pretend that the motor, the bell right here, is now unbalanced. Okay? So what we can do is right away we still choose a ESC value. You can keep the same values as your propeller balance that you were doing before. You can keep the same filters, and then each time we hit run, this is actually going to progress automatically, and you'll see what we do at every one in the runs. The only thing that I want to point out here, it's very important, that the optical sensor is now disabled. So basically this is basically allowing you to free run the motor. So with that in place, again, we're making pretend here that we have a motor that is unbalanced, and I unbalanced it with the with a piece of tape. This is basically could be a motor that you just took out of a box. We're actually going to begin an initial run. We're still going to get samples of our accelerometer. Now notice that really this vector doesn't point in any direction. This thing is going to be going crazy. It's going to be pointing in any direction, because again, there is no reference and there is no optical system. And after each run, we're going to get a magnitude. Okay, so now again, pretending that this was our motor that we first took out of a box, we're going to take a trial weight. Again, another piece of tape here. And what you can do with this trial weight is, before you actually place it on the motor, you can get a very fine granular scale and weigh it. I am not going to weigh it in this type of an example, but I'll show you how you can use the weight, because doing this method is also going to allow you to determine the amount of weight in the direction that then you would need to add to balance the motor. So the first thing that we do is, very importantly, we now have to place this at our 0 degree mark of our motor, which is right here, which again I have marked on the motor, and that is this mark right here. I'm going to take this piece of tape and I'm going to place it at the 0 degree mark as accurately as possible. Okay? And then I'm going to simply hit run again. You'll see that automatically when I do that, it automatically will advance to the second run. Okay, we're going ahead and take a run. And as you can begin to see here, that's really the process, right? We take a trial weight and we place it at a 0 and then 120 degree apart for 3 other locations on the bell of the motor. And then when that's done, you'll see that we're going to get a result that we can then analyze to tell us which way the imbalance of the bell is. Okay, so we placed it at the 0 degree mark right here. We are now going to go clockwise, and we're going to place it at the 120 degree mark, which is marked on the motor right there. Make sure this thing sticks. And then we're going to do it again, obviously, for the last remaining 120 degree apart from this side. And we're going to take another run. Again, the counter or the 4-point location on the motor is going to automatically, in the software is going to automatically advance for you, so you don't have to remember to click, 1, 2, 3, 4. Just keep hitting run, and this thing is going to automatically advance. And then I will tell you how we can actually interpret the results. Again, the vector really all over the place because there is really no optical system involved. And then the last, here's my another 120 degree mark here. So we went 0, 120, and then another 120. And this will be the last run. Again, this is pretty sticky tape here. Just want to make sure it's on the bell of the motor. Okay, and then we hit run again. Okay, so when this is finished, I have another screen here, but automatically what you'll begin to see, what you'll see is that this screen here sort of automatically come up in the software. And then what you see on the bottom here is you see the magnitude of the 4 different runs. This was the first run. Again, we may pretend that this is just a plain motor. This was the second run with our weight placed at the 0 degree mark. The third run, 120 degrees, and the fourth mark, 75. So right away, by looking at this result here, you begin to see that when we placed our weight at the second location, the 120 degree location, the magnitude, at the third location, which the third run, okay, so the first was with no weight, the weight here, the third right here, we got the magnitude to be a lot less. Now you can actually also, we can zoom in here, you can scale this, right? So you can get a better view. So, without really analyzing anything here, just by looking at my numbers, I'm pretty safe to say that if I was going to place a weight at the motor, really at the 120 degree mark, that would have balanced it better than what it was originally. But let's assume that you didn't pay attention to this. How can you determine this? In any classical 4-point balance system, what you see here is you see the 4 circles of our of the 4 runs. The first circle was with the motor plane. The second was with the weight at 0, the third, and the fourth. And basically what we want to look for is we want to look for a spot around the motor that all of these circles intersect. Okay, and also noticing that our third run was the run that gave us the least vibration. It's pretty safe to say that in this direction is where the motor is imbalanced. In actuality, where the circles intercept or as close, you might get the circles that intercept, or a circle here doesn't exactly intercept this. You have to basically find the spot or as close as possible to the intersection of all the 3 circles. And this spot right here, for me, seems to be the spot that it was. And then again, to point in that direction in case, they also intersect here. Yeah, but the yellow one doesn't. So it's really in this direction. And then if we were actually going to add a trial weight, remember we added a piece of tape that we should have weighted before. We can pretend that, I don't know, this piece of tape was, let's say, 0.01 of a gram. We can then, if you click on this screen here, you will see that there is a white line and a marker here that gets pointed to where your mouse is. We can take that and bring it to that point where we think the circles intersect, and then you can actually, move that. You can fine tune it with the markers here. Try to bring that red dot. Now, obviously, this is scaled, so we would actually need to do it in this manner. And then, I have some other features here coming up that will actually take into consideration the scale. But, that's a pretty safe bet, right, that this is the imbalance. And it would also tell us here that if our original weight was 0.1 gram, but now, at a vector of 45 degrees, I'm sorry, the vector of magnitude of 45 and angle of 331 degrees, but we know already what this is because, again, we marked it on the bell of our motor. If we were going to place a weight of 0.0069 grams, and then again you can fine tune this here, you can see as you move the vector, the weight also moves. Okay, but again, it's safe to say that this is pretty much the point of intersection of these circles, that this motor would have been balanced. So if we take a look at our motor here, if we take a look at the motor, and we remove this trial weight, right? This was the original imbalance. We remove this trial weight, okay? And we look at the reference marks. This was the 0. This was 120, the first one. This was the second 120. And this is where we purposely put the imbalance. You'll see where our circles intersect with the screen is basically here, in this location. And if I turn the motor around, well, guess what? Where I purposely placed the imbalance is completely opposite. Here's our 120. Here's where the imbalance is, where it says we need to place the weight to counterbalance this weight here. So as you can see, this 4-point balancing run required no reference other than a trial weight that was placed strategically 120 degrees apart on the bell of the motor, and using our tool here, it automatically pointed to the direction where we need to add weight in order to counteract that imbalance. And if we take that weight, right, and it's 0.067 grams, right, and we placed it specifically here on the motor, then we have another run. You will see that your vibrations have been considerably reduced. And pretty much, that is the process of 4-point balancing your motor. Now, obviously we want our accelerometer, especially for a motor that is very, very well balanced, to be as sensitive as possible. So this is where you need to do a little bit of trial here to try to determine what really gives you good vibrations, just like the song, to be able to determine very minute adjustments that you need to do. Most of these motors these days, especially good quality ones, like I have a Sunny Sky here, come pretty well balanced, so you probably don't need to go through this process. But if you do, and you really want to find out how well or how not so well your motors are balanced, go through this 4-point calibration procedure, and it will basically give you a very good indication here of how well or how not too good the bell of the motor is. I'm planning on some additional releases to the software that will probably add additional functionality here. I'm basically using magnitude 0 of an FFT, and we can see if we can improve on that a little bit. But also, maybe give better control here on the scaling. But, I just wanted to basically show you the process that you go through to determine how well the bell of a motor, is balanced. Obviously, under a perfectly balanced motor, all of these circles would have not really come together at a, at a very fine intersection point here. they would have been pretty much equally, distributed around here, and that would have showed that the motor is very, very well balanced. But in this situation, it wasn't, because by placing clearly a trial weight at the first 120 degree mark, basically counterbalanced the motor. So if this bell was really unbalanced, by placing this weight here would have given us a much better, balanced motor. And again, it all depends on where these three circles intercept, and then having this vector here for you to be able to determine, the trial weight that you need to add in order to counterbalance, that imbalance. Okay, hopefully this helped a little bit to explain how 4-point balancing work. If you have any questions, please do not hesitate to post them on our little RC group forum there, and I'll be more than glad to answer any additional questions. Hopefully you enjoyed this video. Let me see some of the rigs that you've built, and I'm hoping that so far the software has been working well for you to balance propellers, but also balance the bells of your motors. Once again, thank you for watching.